Trying to increase your ROI on IoT deployments? Farmers Fridge slashed their IoT connectivity costs by 50% with Hologram, while expanding to 2,000 locations. Hologram's global solution offers reliable connectivity, easy scaling, and significant savings for smart vending, retail, or any IoT application. Hologram helped Farmers Fridge serve 10 million meals. Imagine what they could do for your business. Ready to boost your ROI? Visit hologram.io today and power your IoT innovation.
Welcome to the IoT For All Podcast. Thank you both for being here this week.
Thank you so much for the invite.
Yes, absolutely. Looking forward to the conversation. Maybe to kick things off, it'd be great if you both could do a quick introduction about yourself and have one of you do a quick overview of the company.
So my name is Liliane Paradise. I'm the COO at Miromico. I'm actually coming from a technical background, studied mechanical engineering and started as an electrical engineer roughly 4 years ago at Miromico, from where I advanced as a hardware team lead and now since beginning of this year in a more commercial role, but also responsible for new technologies, innovations and product development.
My name is Raimondi. I'm CTO of Miromico. My background is electrical engineering from ETH. I'm with the company for almost 20 years. I built up that part where we do electronic design and just diving a little bit more into the company. So we are started up as a design house for electronics, project-based electronics development here in the heart of Switzerland in Zurich. And in the last 12 years, we also changed our business model a little bit towards having our product platforms in the area of IoT, wireless, battery operated devices. And currently, or up to today, we can offer a lot of product platforms for customer specific use cases, customer specific developments. And our main focus is LPWAN technology, so low power wide area networks, battery operated devices, and other wireless technologies.
The first thing I wanted to start out with here is just talk kind of a little high level for our audience's benefit around why is the industry increasingly moving towards wireless solutions in, say, in the industrial setting? What are the biggest drivers behind that shift, and anything kind of related to that, if you could talk to, that'd be a good way to kick things off.
Specifically in an industrial setting, we have noticed that there is a lot of movement in the last few years. We know that the industry is a sector where they're very used to fast communication and wired. But the problem is with wired communication, it costs you a lot of energy to supply these devices. Very often you don't need that amount of data, and it's just very, very costly to build the whole infrastructure, to do the whole wiring, for example, for Ethernet connections or for field buses. And in many of these cases, you actually don't need that amount of data, and you just you end up with a lot of redundant data. And in that case, you might want to move to a more lightweight solution, specifically when it's about predictive maintenance. For example, in a factory setting, keeping all your machinery intact. And in that case, it's a much more low cost and efficient solution to move towards a wireless technology, such as LoRaWAN or mioty, to make sure all your machinery stays intact, as one use case, for example.
And I think it's also offering more flexibility. So once you have a network on your location, it's easy to install some other sensors. You probably start with temperature sensors. And then once you have the network, you can just add sensors. There's a huge ecosystem in all those technologies. You just can buy off the shelf devices and just increase your data collection at almost no cost once you have the basic infrastructure set up. And this is very low cost compared to wired infrastructure.
Yeah, so I would definitely say companies need to reduce their operational costs, and they can easily do that by using IoT. But I also see a lot of companies now, specifically hardware or mechanical companies, moving away from one-off hardware sales, want to use IoT also as a new revenue stream to sell digital services rather than just the mechanical product themselves.
That's a great point. You mentioned LPWAN in there. Can you just high level explain what LPWAN is for some of our audience who may be new to the space? We've had many conversations in the past about it, but obviously there's always new people joining the audience. So maybe we can just kind of touch on what LPWAN is and why it's so well suited for industrial IoT applications.
Low power wide area network. So it's for low power devices, which means basically battery operated or even battery free devices, as we are also having in our portfolio. And it's wide area network. So it means there are the range of those devices is in like hundreds of meters up to kilometers or miles in for your audience probably. So you only need a few gateways to cover a city. So like a city like for example Munich, you can cover with like 5 to 10 gateways. And this compared to, for example, to a mobile infrastructure, it's like a tenfold or a hundred times just a hundredth of the infrastructure you need to cover an area. But of course, with the drawback of having only very low bandwidth, but this is all you need.
Fantastic. And you also mentioned mioty, which uh, is an LPWAN technology for those who are unfamiliar. Can you talk about why that stands out amongst other LPWAN technologies like LoRa and so forth?
Yeah, so what makes mioty special is the so-called TSMA, Telegram Splitting Multiple Access, which means in many protocols, you send one large message. And of course, if you have a lot of devices sending, at one point, they will collide. So what mioty does special is that it splits up the messages in little sub packets, and it splits them over time, but also in over the frequency, meaning that just probabilistic speaking, it's way less probable that they will collide in the air. So that makes it really, really well suited for noisy environments, for environments that are not especially RF friendly. For example, in a factory where you might have a lot of metal, it gives you just a much higher quality of service in terms of transmission quality.
Okay, fantastic. So to walk us through, I guess, in any kind of level of detail that you'd like, walk us through the process of building an industrial LPWAN solution with mioty. Like, well, what are the things that matter? What are the things that are important for people to consider, to think about? Just take us through what that process looks like from your perspective.
First, you have to work on your business model. What is the things you want to measure? What is your kind of amount of money you need or want to invest, and what is your return of investment? Normally, you don't do stuff just for fun, so you invest some money, you want to get something back, and then you decide about the technology. So you probably select mioty for an industrial environment because you know it's the robust one for this kind of environment, and then you start planning your network, uh, looking around what kind of sensors you need. Maybe you can buy some off the shelf, or you can start with off the shelf and go for customization later. And then you also need to think about your data stream. So in industrial setups, we see it's very common to be on premise installations, which means the data doesn't go over the internet, so it all stays on location. But for like smart cities or other setups, you also route the data through the internet because you next to the sensors you will have the gateways, and the gateways will deliver the data to so-called service centers in IoT, and from there the data goes to your business application, your application center, where you do all the magic with like processing the data, storing the data. So this is kind of the steps you need, and for all different levels of layers of those, you need different competence.
And I think one more important point if you're working in industrial setting is to properly choose the infrastructure. And with infrastructure, of course, we're a hardware company, but I mean the whole infrastructure, meaning the hardware and then also the network management and the software, because very often you have remote sites, you have incredible costs to go and replace, for example, a piece of hardware that's not accessible. It might not be accessible because the hardware fails or a piece of the software fails. And there it really makes sense to plan ahead. We have seen a lot in the past that the companies, they just had fun doing digitalization and, oh, let's do a POC. And then they failed because exactly they just thought, oh, we put together some dev boards and that's my IoT case and that scales. And the thought about scaling and quality or quality of service, that really needs to be planned ahead. And even a POC should kind of be set up in a way that you can scale up. Otherwise, the chances are low that this will actually fly.
Absolutely. And I think the other point it's very important that we've seen is a lot of those pilots kind of get stuck in purgatory, if you will, is just you need to be able to demonstrate real business value. And if you don't do that well, that's going to be something that definitely hinders your ability to get buy-in, get funding internally, get budget allocated to scale, like you're saying, right? And I think those are important things that people need to understand. So you also mentioned something about you're talking about the battery powered devices, but you're also talking about battery free devices. So for those types of sensors where energy harvesting kind of exists, where you're not using a battery, how does it fit into kind of the overall vision of sustainable IoT, which is a topic that's come up a lot?
It's clear that there will be more regulations towards sustainability. Of course, it's great to have a battery powered device that you can install somewhere really remote. But in the end, in 10 years, someone has to go and replace these batteries. That will create a lot of trash, a lot of toxic waste. And maybe that doesn't interest us today, but it definitely will in 5 to 10 years. And battery free or even hybrid solutions where you use energy harvesting to extend battery life will be the only way to make IoT sustainable by itself. Because IoT, the sensors, they should help to increase sustainability by monitoring other devices. But of course, if they produce toxic waste, they cannot fit in the whole economy of sustainability.
But I think there's also a commercial point to it. So in the end, it's all about total cost of ownership. So it's if you buy the sensor cheap, you go change batteries like after 2 or 3 years. If you buy a more expensive energy harvesting device, you have to invest more in the beginning, but your total cost of ownership will be there will be a break even point after like 4 or 5 years. But of course, for a management, it's harder to justify a larger investment because you're probably only there for 5 years, and then after everything after that is maybe in the don't care area for yourself. But in terms of like the overall look at a sustainable and long term IoT solution is really the total cost of ownership, and that this starts with buying the devices. So if you buy hardware for cheap, usually buy it twice, and also all the maintenance over time. This is from the devices to the gateways and everything in the system. So gateways that are failing, you have to pass by every other week to reset them. It's just creating costs, not visible on the ordering costs when you install the devices, but definitely in the budget of the overall pro.
Yeah, I mean, you can imagine the need to have to go change the batteries out of thousands to tens of thousands to hundreds of thousands of devices in X number of years, which would be I imagine could be quite a nightmare. Assuming obviously the deployment everything's working the way you want it, but now in order to sustain it, you need to do that, right?
Yeah, that's a nightmare. Yes.
So let me ask another question about the application side. So what are the main challenges of designing for ultra low power or energy harvesting applications? Like, are there unique challenges to it? Anything that's different from kind of the other side of this, or maybe it's very similar, but just kind of curious your thoughts on kind of what challenges or unique challenges kind of pose when you kind of go this route.
Well, one unique challenge that you have when you design a completely battery free device is that you have to consider the case where your device goes out of power. I give you one example. We built a battery free room monitor. It uses indoor light harvesting. And of course, it can survive. We do have a capacitor as a storage element. Maybe it can survive for 30 days, but you have to consider um, it's 30 days in the dark and after it dies. And then you have all these edge case behaviors before it dies, just after it dies, that you need to test very, very carefully. And of course, you also have to test the other side. Basically, when you're oversaturated by light, what does that do to my device? So you have all these new kinds of edge cases that you need to cover. That you first have to gain experience on how to even set up the testing properly.
And of course, you also have to select your components, your sensor devices very, very carefully because just the level of energy available to your system is somewhere where you some sensors you cannot even operate with that less energy.
And even you get one resistor wrong on your board, and that might kill your device in the field over long term. So that's it's really tough.
I bet. Now, all of this obviously takes time to do, right? And getting to market in today's kind of environment, the faster you can get to market, oftentimes the better. It's very critical in the IoT space today. So, how are you all, just specifically with what you focus on? how is your product platform helping companies get to market faster when they come to you with an application idea, use case idea? Just talk me through what that looks like and kind of where you play a role.
I think you can always imagine it like a Lego system. So we have different building blocks, like already implemented or tested sensor setups, piece of software, um, test systems, and you can just plug and play them together. Of course, there is some integration efforts that needs to be done, but it's like the single components, the single building blocks are used in other products. Hardware is already done. Test concepts, test systems are done, um, and you can build. In the end, you can build your own sensor, or IoT device out of whatever we have in our portfolio.
Or we can build it for you. That's one of our major unique selling points, that we have all that experience, we have all these building blocks, and we can help other companies uh, bring their vision to an actual product in much shorter time to market, because we already have everything on hand.
Now, one thing I was curious about, you were talking about when we were talking about the kind of the device life cycle, the need with battery power to potentially change batteries out versus energy harvesting. We know in the IoT space that technologies evolve very quickly, whether it's a connectivity piece, the hardware piece, you name it. Customers oftentimes, I imagine, want very long-term product availability, but how do you balance that with these short hardware life cycles and that need long-term support or have those expectations for long-term support? So how do you kind of balance those two areas when you're working with a company?
So I think there's kind of two different areas in the area of gateway. So the main connectivity device in an IoT network or in an LPWAN network is in gateways. You can plan for availability of components for 10 or even more years. So of course you have to select some reliable manufacturers. You have to go with chipsets that are on the market and made for industrial use cases. So you can, at least for the core functionality, you can at least guarantee 10 years of lifetime. On the sensor devices, I mean, once one thing you have selected is the technology. So if Mighty goes out of market, there is nothing else you can do. But you're also there, you go for like mainstream microcontrollers made for industrial applications. Sensor devices you might need to replace during the lifetime of the device. But this is constantly our platform library or platform device we have is constantly evolving. So we integrate the latest sensors, and there will be updates in the field for the new devices.
And what's critical there is also to be fast on the market. We've seen that from from some customers, they try to build it themselves, and they basically brought out the product so slow that the technology was almost obsolete when it was launched. So the fast time to market is important, and then also to, as Alex mentioned, on sensor devices, I would actually say IoT will not go out of business, because you can use almost any kind of radio, commercially available radio chip. So if one device, one manufacturer goes out of business, you can just replace that with another common part, and that will make your, at least your technology, live much longer than if you're tied to one single vendor.
And I think Lilian mentioned it. Don't try to do everything on your own. So find the right partners in the setup. Focus on your core competencies. So if you're a data company, focus on the data processing. Have someone else collecting the data for you. Because in the end, if you need to, as a data or software company, you have to take care of firmware or like low power hardware design. It will just take too long, and the market cycles will just outrun you.
Yeah, make use of the available ecosystem. It's there and it's growing every day, and we're so glad to be part of it. And we do the same as well. We build only hardware. We believe that's what we do best, and everything else we rely on partners.
That's great. Yeah, I mean, the ecosystem's always been such a big proponent of any conversation that I've had, just like emphasizing the importance of it, which I guess it does also play a role to something you mentioned earlier, which is companies that get to proof of concept and maybe get stalled out versus the ones that actually move on to a large scale deployment. So if we think about that and what often causes those hiccups from getting from proof of concept to a deployment or scale deployment, what are some of those unknowns that most people trip up on, or how, what are those challenges of moving from proof of concept to a full scale deployment that are worth kind of calling out here that are really prevalent today?
I think one thing is doing the deployment right. If you start with 100 devices, you can manage those devices probably with an Excel sheet. You have one of your employees sitting down, tracking all the device numbers. But if you go to scale 1,000, 10,000 devices, Excel sheet is not no longer the way to go. So you need a real deployment. So you need, in the end, with the most of the ID device, you need to know exactly where the device is sitting in the field because you're getting measurement data. And if you cannot relate those data to a physical location, the data point is basically useless. So this management or like the deployment strategy on how you bring the device into the field have the guy that is going to install the device. He needs a certain level of education. It's not just going out there, throwing the device to the corner and go back and job is done. So this is one of the very important part in having a successful IoT deployment.
One thing I wanted to actually ask, it kind of relates to this, is I imagine what we've seen is that there's an increasing demand for on the performance side of a solution, the performance side for the hardware, for instance. But there's also expectations that the battery life lasts, as long as possible. How do you, in the work you do, and how have you seen this kind of get tackled? How do you prioritize or navigate these oftentimes competing requirements that may come up in conversations with customers?
So I think there are two important points. One, of course, is smart hardware design to optimize the design and to tweak it to the very last bit. I mean, chips are getting more power efficient, of course, but the other important side is to educate the customers or the end users. Uh, for example, one example is I want to track a device and I think I need to have a live location. But then if you educate your customer that actually their use case is really just to know before it arrives to a warehouse, for example, and you can maybe increase your battery lifetime by, let's say, a factor of 10 just by not sending the location every 5 minutes. Then they suddenly start to realize what their actual value is when they do their strategy.
This is an important factor if you have to select your hardware components. If you go with off-the-shelf devices, you're probably very limited in what the firmware can do. And so there is no way to optimize the power consumption or the actual usage pattern of the device to your use case because the device is just doing what it's capable by the firmware. But if you go for like a customized device or semi-customized device, um, you can basically adapt the behavior of the device to exactly your use case. And this is one of the most power saving factors because you can actually shut it down whenever you don't need any data and you can bring it to full life whenever it's crucial for the application.
And you can even have event triggered messaging, for example, because usually the messaging or getting a location, anything radio related, is quite power hungry. And we really like to work with this event based messaging or alerting.
We've seen and we've had people kind of talk about similar situations where the customer will come with all these demands and expectations. And once they get a little more educated on not just what's more possible, but also what makes the most sense for their use case, they start to kind of wind down and, walk back some of their initial requests and realize they don't need certain things like the real-time reporting versus, potentially more interval-based reporting. So that's really good. The other piece I think is worth talking about and oftentimes comes up through that educational process is around regulations and certification requirements, which can oftentimes slow development of an IoT deployment. How do you approach like meeting these with while still hitting aggressive, maybe time to market goals that you set? Like how do you kind of balance that, keep yourself as well as maybe the customer educated on things that are happening on the regulatory and the certification side?
So one key factor for sure is that we use our own building blocks. So we have our wireless modules for the end nodes, we have our gateway cards for the gateways, and we already have them pre-certified. And for example, for the gateways, we really have a platform with our building blocks that we can just plug and play everything together and then just do a final, let's say, shorter certification cycle because everything is already pre-certified. And then the other thing is that we do pre-measurements before because certification that can take you a few months up to even like a year depending on what certifications you need to get. And what we very often do is to do a pre-measurement which will be sufficient to start your proof of value, and you can already prove that your business case is valid and you're getting out of the data what you need need to get. And while you get more funding, we can work on the certification.
With the work that you all do, your company kind of as a whole, what distinguishes you all from other hardware IoT companies in the space? Like, how do you separate yourself from the the other companies that exist? And what are the competitive advantages that you focus on? What's most important to you to help your customers succeed?
One thing is flexibility, and the other thing is innovation. So um, we are working customer centric, customer focused. So it's about understanding what they need. So maybe also ask some question: do you really need to have like one measurement every minute, or can we optimize the use case? It's not just you're not providing off the shelf hardware. So we really need to understand the problem. What is the customer want to what do they want to solve? What is the kind of the basic issue? Sometimes they come to us, we need a temperature sensor, but we have to find out what you need to measure for. Why do we need temperature measurements? I mean, this is understand the basic need and maybe also question their way to approach the solution.
Yeah, definitely. So it is our unique selling point that we really take the customer by the hand. And we are also very, very active in the IoT network. So whatever we can provide, we will always connect our customers to. And we will never aim to be that company that offers every possible off-the-shelf device. We really have our platforms, and from there we do it customer specific.
And we know hardware is hard. So there are a lot of challenges.
Mm,
Even if you have your first prototypes, um, bringing that stuff into production, having a reliable production setup, managing all the supply chain with sourcing components, mechanical manufacturing, and
quality
testing, quality
control.
control, having the right numbers on the devices, labeling, packaging, logistics, just to name a few. And you cannot change the hardware once it's done. Software, you can, worst case, do a last minute fix before you go into the big deployment. But on hardware, it's not possible.
Yeah, I know. I understand. I think that's one of the things that most people get worried about, right? Is does the hardware do everything that it needs to do now and into the future, even if we're not thinking about all the potential edge cases on what we want. But I do think it's very important for companies to pick out and work with an experienced hardware company that can help you think through all this stuff early on, make sure you're covering all those edge cases and preparing you and help setting yourself up for the best chance of success, and not only in the pilot but also beyond in a full scale deployment, which is where everybody hopes you get to. So the last thing I want to ask you is, just for audiences listening to this, might want to follow up question, learn more about what you have going on. What's the best way that they can reach out, engage, and kind of discuss things further?
So definitely through our website, we have our public email address, which is rfi@miromico.ch. Otherwise, always feel free to DM Alex or me directly on LinkedIn. We're always happy to engage in new conversations, answer questions, and so on.
Well, appreciate the time. Thank you so much. This was a very good, very productive conversation. So excited to get this out to our audience and hopefully talk in the future.
Thank you so much. It was a real pleasure.
Thank you.